So good morning, everyone. Yeah, it's a real pleasure for us to basically talk about two ongoing research projects that we are doing at BFH. One is an InnoSuisse project where I will talk about first, and then the second one is an SNSF-funded Synergia project that also funds the PhD of Luca, and where he will talk about. But Luca can introduce himself first. Ooh.
Okay, yes. So I have already been introduced as a PhD student, right, at BFH, but also at the University of Bern. Previously, I was a machine learning engineer for BSE, and now I'm working on a very interesting SNSF project on sustainable public procurement, and especially it's an interdisciplinary project, so I am in the NLP part, but I will tell you all about it later.
And I'm Marcel Gygli. As already mentioned, I'm professor at BFH for the topic AI in the public sector. I have a very technical background. I have been doing computer science basically all my life. I also, as Jacqueline previously pointed out in her keynote, we were involved in the development of the topic modeling at the Parliamentarian Library. And previously, I've also worked for a year at Swiss National Library, where I showed how AI could be used inside the Swiss National Library for doing their work more efficiently. But today, what we want to talk about is how can we leverage large language model for public procurement. And the first part in everything almost that has to do with large language model is data acquisition. And luckily, at BFH, we have a large data store of publicly available data related to public procurement through a product that we've been developing and currently developing, which is named IntelliProcure, which basically scrapes all the publicly available documents that are being made available through CMAP. We download all the data, we store all the data, and now we want to see and investigate how can we use that data with large language models. And the basic process is as follows, or like our imagination. So first off, we have CMAP. All public procurements go through that. You can find all available currently available tenders on CMAP, and if you want to participate, then you can participate. And through CMAP, you basically get two things. You get the notifications, which basically are the general information. Hey, there's a tender, but you can also download all related tender documents. And the tender documents come in all the various formats you can imagine. They're Excel files, they're Word files, they're PDFs. It's very, very diverse, the data that you get through that. And one of the biggest challenges we are currently facing is building data extraction that works on all these diverse forms. And that's not easy to solve. And then through IntelliProcure, with all of that data, we basically built a data store of customers. Currently, we have about 5,300 customers that have made tenders, and we also know a lot of the suppliers that have participated in public tenders. And from the CMAP notifications, we know a little bit of additional metadata. We know the CPV codes that give us information about the topic in which the tender happened. So if it's an IT procurement, or if it's house building or procurements for orange juice or whatnot. The CPV codes can be very detailed, and this is one of the biggest one challenge that we are trying to solve, because what we see is that people who write tenders don't necessarily know the best CPV codes for their tender, and there a lot of mistakes already happen. Then we know the tender, we know the award criteria, and we know additional information. And currently, we have a user interface that basically can be used to search information on tenders. And what we want to build in the future now is an additional API that can be used in order to build tools on top of that can be used by authorities to scrape data, and it can be used by providers and consultants. And in this process, we want to investigate how we can leverage AI and large language model. So for example, we want to be able to provide the relevant documents or formulation help, so that someone that wants to offer a tool could basically be like, okay, I identify the person wants to write a tender for orange juice. We've seen 20 orange juice offers in the past, or 20 different orange juice tenders in the past, so we can provide formulation help for writing a good tender for orange juice. Or we also, as we will see by Luca, we want to provide information regarding the sustainability of a tender. We want to provide suggestions for the CPV codes so that they get more clear. And we want also be able to provide suppliers more concrete information which tenders could be interesting to them. Because what we hear from suppliers is they spend a lot of time reading through public tenders, trying to figure out which ones they should write offers for, and we want to be able to provide information to the suppliers, hey, these 10 new tenders could be interesting to you. And currently, we have already one example in place. It's very basic, it's very new, but I still want to try and quickly demonstrate it live, where you can come with a question in natural language. Now I need to close this. Go here, and so here I can come with my question now. So basically, I tell them, hey, I want to have someone that builds me a computational center, and then it searches. And basically, what I find now are similar tenders that have happened in the past. And then I can read through how they made their public tenders. And these are the type of things we want to develop in the future, such that people get the right information much, much faster. And with that, I hand it over to Luca.
Thank you so much. Now that you know about IntelliProcure and about where we get the data from, I will talk to you about our research project on sustainability. And first of all, our goal is really to see how sustainable these different call for tenders are. And there is a law that says that you should actually have such sustainability criteria in these call for tenders, but we want to see if that law actually had an impact. So this is a very interdisciplinary research project, and I'm in the part where we are trying to analyze these call for tenders with natural language processing. So this is also what I will be talking to you about today. And first of all, as you have seen in IntelliProcure, we have really a lot of documents, and these look all different. So if you look, for example, at this document here, this is from a part where they talk about award criteria, and you see that here we have some kind of ID like ZK1, ZK2. We have a name for the criterion. Below, in parentheses, we have a weight. So here the information is mainly in the headers, right? But then if we will look at another document, so here we are not talking about award criteria, but about selection criteria. Here it's more like a column-based layout, where on the left we have at the bottom a criterion Bautermine, and then we have some kind of sub-criteria in the middle part. And for us, like the right part here is not that important. Then here is another example with a very structured design, but I say structured, again, this is from a PDF, so once we do OCR on it, it's not that structured anymore. But of course, there are approaches that we can use to extract these tables more efficiently. But here we have most of the information right in the table. And then maybe one last example that I wanted to show you here is also, again, column layout, but now we have the IDs on the right-hand side, and below is the weight. Then we have the name of the criterion, and on the right-hand side we have a description. So very different layouts, and this makes it very difficult for us. Why? Because what we want to do with this information is that we want to extract it. So, for example, if we take this table here that we have seen earlier, we would like to extract these parts. So, kind of an ID, because in the text they refer to that criterion often by, for example, in this case, set 2 or set 3. Then the name, of course. It's also important for us to know the weight and the maximum number of points that you can get for that specific criterion. And we want to extract that in a structured way. So I hope you enjoy the next slide, because it really took me some time to do this animation. But yeah, we want to have it like in this, for example, JSON output, where we have a list, and each entry of this list is a criterion. So we have the name, we have the weight, we have the maximum score, and we have some kind of ID. And of course, this is not everything. We still need the description of the criterion itself. But this is like just a demonstration of what we want to extract. Then, of course, once we have that, so we already tried that with award criteria, we have to do it with the rest of criteria yet. That already works somewhat well, and this is also where we use large language models, because this task has been very hard in the past, especially if you have these very different layouts. But with large language models, this gets a lot easier, and we are constantly evaluating other models to see which ones work best. Then the next step, as you can imagine, is very difficult to say how sustainable a call for tender is, because they have different sectors. So for each sector, we need some kind of definition of what sustainability means. And what we have now are the sustainability recommendation, which is a compilation from different sources. And in this case here, this is an example from the food sector. And they have like overall sustainability criteria, let's say, which is, for example, that you use more varied proteins, that you use less meat, and essentially plan more vegetarian or vegan meals. This is like the overall recommendations, but then you also have like specific recommendations, like, for example, use at most 120 grams of meat per serving. And what we need to do in the NLP team, let's say, is to be able to identify that a phrase inside one of these CFT documents, CFT stands for call for tenders, is talking about one of these sustainability like guidelines or recommendations, and we need to be able to have like sort of a semantic match. So we need to know that this text that is highlighted here talks about the same thing as the recommendation in this table. Once we have that, this is our end goal for our pipeline, let's say. So we have one call for tender that comes in, which has multiple documents. This is then passed to our AI system as an input, and it analyzes like how well these or how many of these recommendations are actually present inside of these call for tender documents. Then we have some kind of score for each of these recommendations. Like 0 would be that this recommendation is not even mentioned. Maybe, let's say, 1 would be it's mentioned and it's also very ambitious. And this is depicted here in this image with the different colors. Now we have such a score for each of the recommendations. Then we need to somehow aggregate that. Maybe it's a sum, maybe it's some other kind of aggregation. We still need to figure that out. But once we have that, we can essentially say that this call for tender has a sustainability score of, let's say, 78.65%. We are not sure yet if we will be able to have like this bounded score. Maybe it's something that just goes up, and the higher it is, the better the sustainability. Yeah, that's where we're currently at. And maybe one last slide. So we also did some very naive first analysis where we just looked at some keywords and at the different call for tenders that were published between January 2018 and November 2023. And this is what you see on the x-axis, and on the y-axis you see the number of documents or the percentage of documents from that specific month that mention at least one of these keywords as an award criterion. And what we think we see, or what we are wishing to see, is that here where the new law was introduced, there is a raise in mentions of such keywords. And this lets us look optimistically into the future, and we hope that once we have our very complex system for assessing the sustainability of these call for tenders, that we will see the same picture essentially. And with that, I would go to the questions if there are any. Thank you so much.